Okay, I think we are live. Welcome everybody to JuliaCon 2022. It's a very exciting conference, and I'm pretty excited to be presenting the first workshop, the first pre-conference workshop. It's an introduction to Julia language for very beginners and newcomers. It's very accessible. First of all, let me present myself. I am José Storopoli. I'm originally from Brazil and I live here in Brazil. And we do have a lot of comments. Okay, welcome everybody. Yeah, nice. Good morning from Calgary. Okay, good morning from São Paulo, Brazil. Actually, good afternoon, sort of here. So, I'm associate professor here in Brazil at a university called Uninove. And I also work at Pumas AI, which is a Julia-based pharma company. And I'm also one of the authors of this nice book here. It's free, open access, available in 3 languages. I'm gonna show a little bit. It's free for you to use. We have English, Chinese, and Portuguese translations. All translations were done by volunteers, so that's pretty exciting. So today we are going to do a 3-hour workshop, Introduction to Julia. We are going to have 5-minute breaks, and I need to hide this thing. Okay. And we are going to do a 5-minute breaks every 45 minutes. So at 10:45, those who are in the Eastern, New York, Florida time zone, or in 45 minutes, we are going to do a 5-minute break, and we are going to keep doing that until we hit the 3-hour mark. That's how we are doing it. Okay, good morning, 12 a.m. from Sydney. Okay, good morning, Viraj. Welcome to JuliaCon. So, first of all, let me just share my screen. I'm gonna share. So, I think you guys are seeing this. Today we are going to be using an IDE that's integrated development environment, which is called VS Code. It's one of the most popular ones that you can use while you are doing Julia programming and doing Julia stuff. First of all, why should you use Julia? I have some opinions. It's my opinion, so I don't know if everyone else agrees with me, but I'm going to disclose them right now. It is fast. It is very fast. That's one of the catching points of Julia. The third thing is that you don't need C++, Fortran, or any other what we call slow productivity or languages that you need to compile, and it's really difficult for you to prototype. This is something that we in the Julia community calls the 2-language problem. So you prototype something in an easy but slow language, and once it works, you need to implement in a fast and hard language. So that's what we call with the 2-language problem. It has a friendly syntax. Those of you coming from MATLAB or Python, you'll be very familiar with the syntax. We'll go really easy today. It's very accessible. It's very easy to install. You don't need a C++ toolchain or a compiler like other programming languages that you need to install a lot of stuff, and it's very complicated, especially if you're using Windows. One nice thing is that we can do Unicode characters and we can do our favorite LaTeX. So no more alpha and beta. Hello to this alpha and this beta. So this is something that I love it, because you see an algorithm in a textbook and it's a one-to-one translation to Julia code. And this is really nice. As I said, it's really easy for you to add new stuff, to prototype new algorithms that are straight from the gun. straight from the get-go, really fast. And lastly, this is one of the also selling points of Julia. Project management and making reproducible environments is really easy. They are baked into the language, into the standard library. So every install of Julia will have, by default, all that you need to do project management and reproducible environments. So you don't need to mess around with third-party solutions or to onboard or teach your collaborators how to have reproducible environment, how to have the same environment as you do when you are coding with them in a collaborative fashion. We do have one question here. So we have this someone is asking, is it from the basics? Yes, it's from the basics. Our target audience is people who have not even seen one single line of code in Julia. We assume that you have a basic knowledge of programming, that you either knows a little bit of Python, R, or MATLAB. And because some concepts, we assume that you are familiar, like the concept of types, variables, but it is from the really, really basics. That's it. So as we go into the real basics, let me share another screen, 1 second. So how do I install Julia? You go to the julialang.org website, and there is the first top banner. It's download. It says download. You click on that, and you get into the downloads page. And always go for the stable release. If you need something else, you can go to the long-term release. But generally, for like daily usage, your stable release is fine. It's from May 6, 2022. And here you can pretty much go into your platform. So if you are a Windows user, you have a 64-bit installer here. It's an .exe, so it will install Julia for you. If you are in a Mac, you need to download the DMG file. It will install Julia for you. And if you are in Linux, either x86 or ARM architecture, you also will have binaries here for you to download if you are using glibc or Muslim systems. If you don't know what that means, don't worry. And of course, if you are a true hardcore user, you can always get the source code and compile it yourself. But it's really easy to install. You just go into julialang.org and hit downloads button and choose your platform. And you pretty much either get a binary, like a file that you can execute, and it will be Julia for you, or you can pretty much get an installer like a windows.exe or a mac.dmg file. So we got one question. So yes, we are going to get a little bit into how to add packages. But we are not going to go in depth into that. But we are going to definitely talk a little bit about how to add packages, remove packages, how to activate an environment. Okay, let's see if we have questions in the Pigeonhole. I don't think we have questions so far. Okay. let's move on. So today's workshop, it's in this GitHub here. I don't know if I post it here, you will see it. Okay. Yeah, there we go. I posted to every channel, so YouTube, Facebook, Twitter, and LinkedIn. You should receive this. So this is a public repo. As you can see, there is nothing here. It's just like a boilerplate code because I'm going to be doing live code. But after our session, our workshop, I will commit those changes into that repository, and you can also visit that later for the full code that we typed in today. So let me stop sharing again and go to VS Code. So if you go to the repo that I just sent you, you see that we have 9 files. They are numbered from 01 to 09. Julia uses an extension called JL. So every file that ends with JL, it's a Julia file. And if you install the Julia language extension, so if you go into your extensions, in VS Code, you will find Julia, and you can pretty much click on that and install. It has around 15,000 downloads, and this is the extension. If it has less than 1,000 downloads, you are probably in the wrong extension. So that's how you do it. You click on install, it will install by default, and it will bind to every every file that has the .jl extension. If you open that file in VS Code, it will by default run the Julia extension. So that's the idea. So let's open the file 1. It's called packages. And we are going to showcase how to add packages, how to remove packages, and how to add a specific version. What are those things called? Project Toml and manifest, commonly called the Toml files. How to update your packages, and how to clean your outdated or unused packages. Because if you keep adding a lot of packages, sooner or later, you will probably run out of disk space. So it's a common habit to always clean outdated or unused packages. So let me just open a new repo. I can go here in this gear icon, manage. I go to the command palette, and I have Julia repo. So where is Julia? I think it's repo. Yeah, it's this one. Julia start repo, or you can go in the keybinds that this shortcut has. So for me, it's Alt J, Alt O. But for you, might be another thing. Maybe if you're in a Mac or a Linux or Windows, it's different. So I'm going to start a repo here. Let me put that down here. So we have a little bit of space. Here is a Julia repo. And as you can see, I can type in the repo if I want to. I can, and if I do something like, let's do float, and I hit tab a couple of times, it will autocomplete for me. So we do have autocompletion. There's also a nice workshop from Miguel, and which will cover Julia's repo mastery. I think it's on Friday, maybe. So check JuliaCon's JuliaCon's schedule. So first of all, how do I use packages? We do have some packages that comes with Julia. These are the standard library modules, what we call. Let me showcase, I'm a statistician, so let me showcase the standard library statistics module. So I load the packages with the using statement. So Julia has a using statement. It's pretty similar to the import from Python, or from R, it's the library function. So these are similar. And Julia, we generally use the using statement. So I'm going to use the statistics. As you can see, there is a small tooltip here telling us that the statistics is a standard library module for basics stats functionality. So I pretty much hit the autocomplete. And now there is one nice thing in VS Code. We have some keybinds to send the line, which we are currently in, to our terminal. You can do either Control Enter, so this sends this line here. So I pretty much hit Control Enter and the line was executed in the REPL. If you want to execute the line and move forward, you do it Shift Enter. So Shift Enter will execute the line and move forward. And it moved forward because in Julia, it's similar to R and Python. The hashtags, they are comments. So that's why pretty much it went to the end of the file, because we don't have anything else. We just have comments. So that's the idea here. That's how we import packages into our environment. But to get these packages imported, we need to install them. How do we add packages to our environment? So we go to the REPL, and I'm going to type the right bracket. When I do that, you will see that the REPL will change color, and it's not going to showcase a Julia. It's going to showcase a PKG. That's short for package. So if I hit the left bracket, you see that it has changed to PKG, and also the color has changed from green to blue. We are in the 1.7 environment. This is my default environment because I'm using a Julia 1.7 version. And we can pretty much do a help here. It will showcase some commands that we can type in this special blue REPL. So as you can see, the one that we are looking, it's called the add. And we also have the remove, or RM. And we also have a nice one called status, or ST. So for example, suppose I want to add a package called, I don't know, let's see a package that's not going to, okay, benchmark tools. So if I do that, it will add benchmark tools package into my environment. It's going to do a little bit updating. And as you can see, benchmark tools has been added to the project TOML. We also have something that was added to the manifest TOML. We'll cover that in a moment. And if we do the status, you see that we have now 5 packages. I already had those 3 packages, and I added the benchmark tools. But I can also remove packages. So let's remove the Pluto. So I can do remove Pluto. That will remove the package from my environment. And it removed Pluto from my project TOML. It also did some changes in the manifest TOML. I'm going to speak a little bit about manifest files in a bit. And if you go into the ST, or status, I'm a lazy guy, so I'll be pretty much typing the least amount of letters that I need to do. but you can also do status, so st. You see that Pluto has disappeared, so we don't have Pluto anymore in our environment. So that's how we add and remove packages. And since we have benchmark tools in our environment, we can import it with the using statement. So I can do using benchmark tools and VS Code, that is the name of the IDE that we are using. VS Code already detected that we changed some things in our project environment, in our current environment, and it also detect that, and it's suggesting as an autocomplete. Do you want to import benchmark tools? Yes, we do. So we pretty much hit enter. And if we send this line with control enter to the repo, you'll see that now we have benchmark tools, and benchmark tools has some nice macros, which we are not going to cover right now. One of those is at btime, that's benchmark time. And as you can see, it's pretty much here. So we successfully imported and added and also removed a package from our environment. So that's how we add and remove packages. We can also do adding a specific version. How do we do that? So let me just go back to our PKG shell. That's what we call it. It's a right bracket. So it's this icon here. I type it. My repo has turned blue, and the Julia prompt has changed to PKG. And if I do status, you see that benchmark tools is version 1.31. Suppose I don't want that function, that version. I want the version 1.2. I can do that with add benchmark tools, and I hit tab to autocomplete. I use the add symbol, 1.2.0. That's how I add a specific version of a package. I do that. And as you can see, it's installing benchmark tools, it's updating. And this is a nice prompt here saying that our project TOML has been updated, actually has been downgraded. Benchmark tools was downgraded from version 1.31 to version 1.2. And to install another version, we can pretty much do the same thing, benchmark tools, and I hit tab to autocomplete. So 1.31, and you see that the prompt will be in another color with the arrow up, meaning that we updated our benchmark tools installation in our environment to from version 1.2 to version 1.31. So that's pretty much how we add and remove packets. Let me see if you have any questions in the pigeonhole. Does Julia have an imperative numerics library like pandas? I love pandas, but I'm actually aware of heavy Python overload of big data. Yes, we do. We have a package called data frames, which is a much nicer name than pandas, I think. It is much more intuitive. Data frames, and it does everything that pandas does, but faster and easier. There's going to be a workshop by one of the lead developers of the data frames package. It's Borgumil Kaminsky. I don't know when, so check the Julia link. I think it's on Saturday, but I might be wrong. So check the JuliaCon's schedule and don't miss that workshop. It's one of the greatest workshops from data frames by the man himself, the one who develops, the main developer of data frames. Let me see another question. The name of the IDE is Visual Studio Code, VS Code. It's easy to switch from Python or R to Julia. Yes, it is. Are those languages similar? Yes, it is. They have a similar syntax. Actually, Julia is more similar to Python than R, but it's easier to switch from Python to Julia because the syntax is very similar. I don't see any more questions here. And okay, that's it. Let's continue. Now, I said that I was going to tell you what's the difference between a project toml and a manifest toml. So I'm going to show to you what a manifest toml looks like. So I'm going to do a help status because I always forget the which are the options. I have a bad memory. So okay, there you go. I want to do status of my manifest. So that is with the flag M or the long flag manifest. That's what to do. C M. As you can see, the manifest toml is way more verbose than our project toml. Because manifest toml is machine generated. So you actually the manifest toml and change the intro. So which is compute in a NVIDIA GPU, and pretty much those three GPU stuff dependencies in my manifest toml, they were included because I did in my project toml, I did something like add CUDA. When I did add CUDA, it already imported all of the dependencies and stick it into a manifest toml. So the manifest toml is machine generated and it has all the blueprint of your packages and your dependencies. So if you want a 100% reproducible environment, you pretty much send your code to your collaborator, you send your project toml along with your manifest toml. And that guarantees 100% that they will have the same environment as you do, the same package versions and everything. So the code will run the same in both computers, in both environments. So that's one nice thing about Julia. And it's right into the default install of Julia. You don't need to install anything to use the PKG options. So that's how we do it. And to get back to the Julia repo, we just hit backspace. So I just hit backspace. I'm in the PKG. I hit backspace. It go back to the Julia repo. Also, please, we do have chats for Facebook, LinkedIn, Twitch, and YouTube. So I cannot keep up with all of those. But I'm focusing all of my attention into the Pigeonhole. So please send your questions into the Pigeonhole. Are we having audio issues? Can you guys hear me okay? Oh, and okay, so it's the internet. Refresh your streams. Okay. So I guess it's not on my side. I'm in a cable connection, so I pretty much know that I have a pretty stable internet. So let's hope. Okay, let's see one more question in Pigeonhole. And please, anyone from the Julia community and Julia folks, post the Pigeonhole. I think it's in the video description also. But post the questions in the Pigeonhole. Post the link to the Pigeonhole, please. Okay, so we have some advanced questions that I'm not going to cover here. because this is the introduction. But there is a, if you want, you can go to the documentation, to the PKG documentation. So just type in pkg.jl in your favorite web search, and you pretty much will land into the Julia standard library module PKG, where you see all the documentation, all of the user case, and pretty much all your advanced questions about project management in Julia between different versions will be solved or answered or pretty much deal in the documentation. So let's move. How do we update packages? If we go to the help again in our PKG mode, you see that we have an update. So I can do pretty much up. I can choose a package. So I can do up, let's see, maybe CUDA. That's a package that I have, and it's updating CUDA. As you see, I had a minor release that was updated from 3.11 to 3.12, and it's pre-compiling all of my packages, and that's pretty much how I update. If you want to update all of your packages, you do just up without any packages. So yeah, I shouldn't have updated CUDA. It takes a while to compile. Okay, so if I do just up, it will try to update all of the packages here. So as you can see, Julia Formatter needs updating. So that's pretty much how I update stuff. The last things, so how do I clean stuff? So if I go to the help again, suppose I have some outdated. Do you guys remember that I removed the Pluto package? I did a remove Pluto. So if you see my status in the project toml, I don't have Pluto package here. I had a Pluto package. I remove it. So if I go into help again, you see that we have a GC command. This command will garbage collect. That's why it's called GC, garbage collector. It will garbage collect all of the packages that you are not using. So if I do GC, it deleted no package, but I can force it. If I do help GC, you see that I have all. So I can force it. I can say, okay, I want to garbage collect all of those. And if I do that, you see that I deleted 6 packages and I released 15 megabytes of disk space. So there are folks that have like gigabytes of unused packages. So if you do gc -- all, you pretty much have like free, I don't know how many gigs of storage, claim it back. So it's a good practice to always do weekly or monthly a gc -- all in your in a fresh Julia repo session. So that's how we do it. Let's move now to the variables part of things. Now I'm going to start doing live coding. So let me take this out here. Let me shift things around. So let me see if we have some new questions. CUDA is to be used with NVIDIA, right? Are there any alternatives for Mac M1 users? Yes, there is. It's brand new. It's still in development. It's still like a beta testing, but you can try it. It's called metal.jl. Just go to the juliagpu.org. I think it's juliagpu.org. And the latest blog post, I think it was from last month, Tim Bezard, which is one of the developers of the whole GPU ecosystem, he just announced that you can try it out doing GPU computations in Apple M1 Silicon. So I think the package is called metal.jl. But check that out. Also, Tim Bezard will be doing a workshop. I don't know when. Check the JuliaCon schedule on how to do GPU computing in Julia. So if you have a GPU and you want to do nice stuff in the GPU using Julia to make Julia even more fast, you definitely would check out that workshop. Oh, that's a great question. The code does not echo to my terminal, just the result. Yes, it's because I went into my settings and I changed something. So if you go into your extensions tab here and you click on your Julia language and you click on extension settings, let me take this out of here. Oh, okay. And you go down here. There you go. Execution code in repo. So you pretty much flag this as on. So then your code will be executed and show in the repo. I like this because it's more verbose. I prefer to always know what's going on in my repo. And also, I changed this execution type to both, but this is the default. But the thing that I changed is this Julia execution coding repo and hit the option box. So then you have the same experience as I do. And this is the only thing that I change in Julia in my settings. Let's close this. Let me see if I have more questions here. Okay, let's move on. I don't see more questions here, so let's move on. Let's talk about variables. So in programming, we have typical variables, and these variables have a certain type. I'm just going to cover the basics one. These are integers, real numbers, booleans, and strings. So let's say I have a variable called x, and I assign this x with the equal statement a value 3.14. So, and I hit Control Enter to send this to the repo, and this is how I do. Oh, this is not integers. Sorry, this is real numbers. So this is how I do real numbers in Julia, and I have some helper functions. So if I do type of, so let's do in the code here. If I do type of x, and I hit Control Enter, as you can see, our variable x, which is a real number, has the type float 64. And float 64 means it's a float, a floating point number with precision of 64 bits. And this is pretty much the standard in nowadays systems. So every system, most of the systems is 64 bits. And that's how we define real numbers in Julia. They have the type, float, and the precision. Most of the time, they will be 64 bits. Integers, let's say I have a variable called y, and this variable is 10, or even better, 22. So welcome to JuliaCon 22. So if I do this, you see that it assigns 22 as the value of a variable y, and if I do type of y, you see it's a int 64, and that's an integer with precision 64 bits. So that's our float and our real numbers. These are the most used types, numerical types in Julia. The integers and the floats, both of them with 64 bits of precision. We also have the booleans, like every other language. So a boolean is a binary variable. Something is either true or false. That's a Boolean algebra. And we can assign, I don't know, let's get a little creative. So mortality. I think that mortality for everyone, it's a true statement. So everyone is mortal. So I can pretty much do mortality equals true. And if I do type of mortality, you see that it returns that it's a Boolean. It's a Boolean type. So the bool type in Julia, it's Boolean variables, true or false. And you can see that there is a certain pattern emerging here. So some things in Julia are like title case. So you saw the bench, you saw the bench mark tools package. So this package is a title case. So benchmark has a capital B and tools has a capital T. Also, the other one that I told, it's going to have a separate workshop just for that package. It's data frames. So data frames, we have a title case, and the types, as you can see, int 64, float 64, bool. So there's a convention in Julia that packages, modules, and types, they are title case. So that's why bool, it's title case, float 64 is title case, and int64 is title case, and packages are title case, and also the standard library modules like statistics are title case. This is a convention in Julia. Everything else is lowercase. So that's why I'm using mortality as lowercase, not doing something like this. That is a nice convention that most of Julia users and developers, they assign to. So that's why there are some things that are title case, some things that are not. So rule of thumb, package modules and types, they are title case. Let's talk about our last type of today. We do have way more types, but I'm just gonna cover the basics. Strings. So a string in Julia, let's say, let's not do Julia, let's do my string. Okay, my string. So welcome to JuliaCon. In Julia, strings is represented by a string of characters wrapped around double quotes. So if I do this, and I do type of my string, you see that this is a string. And of course, it's a type, so it's title case. Now there is one caveat here, one distinction from other languages. So in other languages, notoriously Python, you can do my string too. You can do single quotes. You can do something, welcome to Julia. And as you can see, VS Code is already warning me that this will error, but let's run this line of code and you get an error and a stack trace called syntax. It's a syntax error. Character literal contains multiple characters. That's because Julia makes the distinction between strings and characters. Strings, you use double quotes. Characters, single character types, you use single quotes. So we cannot use single quotes for strings, just for characters. So I can do something like my char C, and as you can see, if I do type of my char, you get back, this is a char type. So single quotes in Julia are reserved only for char types. So only single characters. So strings, you must use double quotes. That's one difference from Python. So you cannot use, you cannot exchange, interleave double quotes with single quotes. So let's see if we have some questions in the pigeonhole. Can a single character be UTF or Unicode? Yes. You can do something like my Unicode share. I think yes. Let's see. Otherwise, I'll get a very naive error live. So let's see. Let's do alpha. Oh no, we cannot do it. Let's try to see if I can do this. Yes, you can do it. So type of, so let's grab um, type of my Unicode char, and it's a char. There you go. We can do it Unicode. And also, to piggyback on that question, how do I type Unicode characters? So if you're familiar with LaTeX, you pretty much do it like in LaTeX. You do it / and the LaTeX command. So if you want like capital Omega, you can do Omega, and you see that you have a small tooltip here, and for completion, and if you choose the first Omega, this will translate to our Omega, capital Omega. We can also do with lowercase Omega, so this is Omega. There you go, we have lowercase Omega. Let me take my mouse out. We can also do, I don't know, we can also do pi, and pi, we can do / pi, and then we hit tab. And pi is nice because that is a constant. So it's defined. So in Julia, as you can see, we do have some constants like pi and Euler for a / Euler, and you hit tab, you get the Euler constant. So E, as everyone knows. So that's one nice thing about Julia, one-to-one math translation from code, from textbook to code, or from paper to code. That's really nice. So let me see another question here. What is the use of character apart from string? The use is mostly for performance. So sometimes you are going to be using characters and it's going to be faster. So Julia, everything is all about performance. So that's why we have different types for character and for strings. Mostly for performance issues. Not issues, for performance motives. What about using quotation inside a string? I think you can do that, but I have never experimented with that. So try it out, and if it errors, you can go to our discourse and ask a question there. Our community is very receptive, and you'll be welcoming yourself into the community, which is one way to get more acquainted to a new language like Julia. So let's move on. I already covered type of. Now there is one nice function called methods with in Julia. It's loaded. It's already available when you load a fresh Julia session. And sometimes I get like a type, and I say, okay, what is this type? What can I do with this type? What functions can I? Which functions accept this type as an argument? So which functions can I use with this type? This is a nice function called methods with. It took me a while to find that out, so I always think it's great to tell beginners because you can empower them. So let's do methods with, and so if I hover in methods with, why you are not showing the help? Okay, let's try. Let's try again. Okay, methods with. So okay. So if you hover over, it should show like help for this. But if you want to know more about a function or know more about anything in Julia, you can go to your repo, type the question mark. So if I type the question mark, it will change my repo from green to yellow, and also it will change the prompt from Julia to help. So this is my help repo, my help terminal. So here, autocomplete also works, so I can do methods to with and then hit tab to autocomplete. So if I do that, and this is the last thing, then we go into a 5-minute break. As you can see, This is the function signature. So it takes a type, a module, or a function, and returns an array of methods with an argument of type t. So I pretty much call that function. The first argument, it's the type. So let's see what I can do with the string type. So if I do methods with string and I hit Control Enter to send this code to the repo, it's going to be pretty crowded here because we have 128 functions that can take strings. So I can do something like match. So match function to doing like regular expressions matching. I can use it with string types. I can also do print. We are going to cover this after the break. I can also do repeat. I can do starts with, transcode. I can do try parse. You have a lot of you currently have 128 functions in your environment that can take a string as a type in one of the arguments. So that's how you do it. That's a basic introduction to types in Julia variables. So let's do a 5-minute break. We'll be back in 5 minutes. I'm gonna set a timer here. Do I set the timer? There you go. See you guys in 5 minutes. So I got some couple more questions before we resume. Ops engineering. How do you see Julia growing into that space? I'm not gonna give my opinion, but I'm gonna invite you to go to Anthony Blaum's workshop, and I might have mispronounced his name. So workshop on machine learning with Julia, and ask him that question. He will be much more. He will give a better answer than me certainly, because he's in that ecosystem. So another question about are Julia packages on Atom editor still supported? Not supported, they are being deprecated. Microsoft has pretty much killed Atom, so we encourage everyone to migrate to VS Code. And Microsoft announced that they would be killing Atom in like 1 year cycle or something. So we've been warned. So move away from Atom because it's been slowly dying. So let's see one more thing. What are some cool extensions in VS Code for Julia? There is just one, I think. It's the Julia formatter, and it is a nice extension. And it's, if you are a Julia developer, you pretty much know about this extension. And Julia developers are sometimes they want the code to be formatted in a certain way so that you create less friction when you are doing development. So this is a nice extension for you to format your code. Let's close all of this. Okay, let's move forward. Let's go to our third section here. And our next break is in 45 minutes. So Boolean operators. Now, Julia, we do have 3 Boolean operators like every other language. It's called, we do have the AND. So if we do something like true and false, we get back false. Because that's, if you go back to logic, the whole truth tables, you see that true and false returns false. So that's how we use it. Second one is OR. So if you go true or false, that returns true. So you use the double ampersand and the double vertical bars for AND and OR respectively. And we also have the negation, the not. So if we do not true, we get back false. So that's how we do Boolean statement in Julia. The AND is double ampersand, the OR is double vertical bars, and the not is a bang. It's pretty much similar to other languages. There is just one caveat. Why we are using double ampersand and not single ampersand? What is the difference? Well, the difference is that if you go to the Julia documentation and you take a look in the help function for the AND, the double ampersand, you see that this is a short circuit Boolean AND. So this is a Boolean operator. And if you go into a single ampersand, this is the bitwise AND. So the single ampersand or single vertical bars, they are bitwise operators. So you would use that in not Boolean comparison. You would use that in a bitwise operation. So I don't recommend you using that, only if you know what you are doing. Most of the time in your Julia day-to-day scripting and doing stuff in Julia, you pretty much will be using the AND and OR operators, the double ampersand and the double vertical bars. So that's the difference. And sometimes that can confuse folks. So single and percent and single vertical bar is the bitwise operator. And this is probably not what we are looking for when we want to do Boolean comparisons in Julia. The video will be, it's been recorded, and if you need to leave the live stream, you can watch it later, but you will miss the whole interactivity and asking questions. But the session is being recorded for later view. Let me see if we have questions. I don't think so. Let's move forward then. Numerical comparison. That is pretty much the same as in other languages. So we have the equality and inequality. So I can do something like 5 equals 5, and I get a true statement. I can do 5 is different than 5, and I get a false statement. And that also works across types. So if I do 5 equals 5.0, which is a float, oh, sorry, let's do equals. Yeah, we get true. So pretty much in those comparisons, Julia will do an implicit conversion to compare those types. Not conversion. It will account that you are using different types, and it will either promote one of those, and it will make a fair comparison. So that's how we do numerical comparisons. We can do equality and inequality. So 5 double equals, it's equality. And 5 not equal is inequality. So that's how we do it in Julia. And also we do have the less than and less than or equal to. So we can do it something like 5 less than 6, and this is true. We can do also 5 less or equal than 5. That's true also. And we can also do LaTeX. So if you want LaTeX, the LaTeX symbol for lower or equal is LE. So we can do \LE, autocomplete that. And as you can see, we have a nice less than or equal to LaTeX Unicode symbol. And this also works. Most people don't like this. They prefer more default stuff. But you can do that if you want to. And the same with greater than. So we can do 10 greater than 2, and this is true. And we can also do greater than or equal to, which is the greater followed by the equal statement. And this is also true. And also the LaTeX command for greater or equal to is GE. So we can do GE, and this is our greater or equal to than, greater than or equal to, and this also is possible in Julia. So that's how we do our numerical comparisons. We can pretty much mix and match those. So we can do something like 10 less than 2 and 5 more than 2, or 5 more than 2. And I don't know what this will spill out because I pretty much type it random stuff. So this is true. And also, let me copy this whole line and paste it here. We can also do the negation of everything, and this is false. So you can pretty much mix and match. Just be careful with the parentheses to delineate the scope of your numerical comparison. So that's pretty much how you do numerical comparisons and Boolean operations in Julia. Let me see if I have questions. What is promotion, Julia? Oh, that's a tricky question. So when we are comparing different types, or when we are doing stuff that that there isn't an explicit way to do it in Julia, Julia will promote some types or will change some types to another type. And I definitely have not prepared to answer this question. So It's been a while since I don't mess with promotion rules in Julia, but if you go to the documentation and search for promotion, you will find pretty much everything that you need there. So promotion is when you get a type and you promote that type to another type. Is an operation in a type. So you have a variable that's one type, and you need to do something with that variable. Sometimes Julia will promote that variable to another type. That's what we call promotion in Julia. Is a Boolean variable not a bit? I mean, everything translates down to bits. That's, I don't know how the Boolean variable will be represented in memory. So probably the Julia documentation will be your best guess on finding this out. Unfortunately, I don't know if Boolean variables will be a single bit or not. But everything will be translated to bits in a computer. Let's move to types. So this was pretty much easy stuff. Now types, we might get a little bit more. We might get a little bit in some nice stuff and not so naive. So in Julia, we have things called abstract types and concrete types. I'm gonna share my screen. I'm gonna share another screen, so hang tight 1 second. So stop screen, share again. So this is, it's a little bit outdated, but I do like this image here because it kind of gives you a brief overview of the type systems, of the type system in Julia. So everything that has a dashed dot, it's a abstract type. And I'm going to explain in a brief what abstract types are. Everything that has a solid line, it's a concrete type. As you can see, everything in Julia derives from a single type called any. And that the n type can be anything, like the name says. We can have subtypes and supertypes. So any is a supertype of every type in Julia. So every type in Julia has an any as a supertype, or in another way is a subtype of any. Abstract types we cannot instantiate. We cannot create objects like variables out of abstract types. We can only create variables or objects out of concrete types. So that's the difference between abstract and concrete in Julia. As you can see, let's change our attention here to the float types. We do have two types of floats. We have more, but here we have two types. In this image, we have two types of floats, two types of concrete types of float. We have float 32 and 64. And those are float pointing numbers with 32-bit precision or 64-bit precision. And they are a subtype of abstract float. So abstract float represents any type of float, but it's an abstract type. You cannot instantiate, you cannot create objects of an abstract type. But we are going to see why they are useful in our functions next file. So hang tight. And let's take a look at the integers. So integers, we do have one abstract type. It's called integer. And we do have two subtypes. They are abstract from the integer type. We do have sign integers that are accompanied by a sign, either positives or negatives. And we also have unsigned integers that the abstract type, it's called unsigned. And they have here represented int 64 and int 32 bits. That's signed integers with 64 and 32-bit precisions. And we also have uint 64, uint 32. That's unsigned integers without a sign with 64 or 32-bit precision. So that's the difference between abstract and concrete types. So let me stop sharing my screen and going back to VS Code. So if you remember, we had x equal 3.4 and y equals 22. So let's run those two lines of code. Now, if I say type of x, that's a float 64. If I say type of y, that's an integer 64 bits, an int 64. Now, I have some functions called supertypes, which will get us back an array, a vector of the supertypes of certain types. So, for example, if I say supertype of float 64, supertype, we get back pretty much, actually not a vector, sorry, a tuple. And we are going to explain those in a bit. And we see that we have float 64, that's the first one. And another supertype is abstract float. After that, we have a higher in the hierarchy supertype called real. It's a real numbers. And then we have number, that's any number. And of course, any is the supertype of all types in Julia. And if we do supertype without, so let me copy this. If we do supertype without plural, a singular, so we get the first supertype, the in line of hierarchy of our desired type. Sometimes we want to do something like we can do supertype and then we can do type of x. So I have no idea what x is, so I can do that. This thing inside will be evaluated to a float 64. So if I just run this, you see that I get float 64. And if I run this line, I get back an abstract float. So we can do that. We can also do something like subtypes. Now, subtypes, we don't have a singular function because generally we have more than one subtype. So subtypes of abstract float. So this returns a vector. And as you can see, we have big float. If you need more than 64 bits of precision, you have a type called big float. We have 16 bits, 32 bits, and 64 bits. And all of those are concrete types. So that's how we check the hierarchy of types in Julia. We also have the nice diagram that I just showed to you. There's also an operator called is-a. So for example, our x, it's 3.14. So if I do x is a float 64, that's a Boolean comparison. So that will either returns true or false. So x, yes, it is a float 64. Is it a float 32? No, it's not. Is it an abstract float? Yes, it is. So if you do an object, you use the is-a operator into any of the supertypes of the type of that object, you get a true statement. It will evaluate to a true statement. So of course, we also have real. Yes, is a real. And x is also a number because that's the next abstract type from abstract float, real number, and yes, and of course, any type or any object is a subtype of any. So this evaluates to true. So we can do the same with the y. Y is an integer, 64. So we can do is y an int 64? Yes, it is. Is it an int 32? No, it's not. Is it just int? Int? It's the abstract type of all integers. So it's pretty much like our abstract float, but for integers. This also evaluates to true, but y is not an abstract float. But y is a real, as you can see. So that's a basic overview of types. Let's see if we have questions. If you have questions, please ask them in Pigeonhole. That's where we are concentrating all of our questions. Yes, sizing bytes. So if I want to get a sizing bytes, you do base summary size x. And of course, a 64-bit precision float takes 8 bytes. You see that this is pretty much obvious, but in some languages, you don't get back an 8. And a lot of popular languages. So that's why you should switch to Julia. Julia is where a 64-bit precision float is just 8 bytes, nothing more. Thanks, Arturo. Why methods like is abstract type, is concrete type doesn't follow camel case? That's a great question. So we have is concrete type. So that is a function. And now my Hoover thing is working. So as you can see, VS Code will pretty much say that we can use any type here. So T is any type. So we can say, okay, is concrete type float 64. Remember the rule of thumb. Camel case is for modules, packages, and types. And this is a function. So this is pretty much lowercase. That's why it's lowercase. It's not a module, it's not a package, and it's not a type. This is a function, so it's lowercase. And we also have the is abstract type. So if you say something like any, yes, it is. So this evaluates to true. That's the idea behind these two helper functions. Is concrete type, is abstract type. Let's cover something called containers in Julia. I don't know if that is the official technical term, but I'm gonna say it containers with double quotes. These containers, they have like a curly brackets. So if I create a vector in Julia, which is analogous to Python list, so I create a vector called 1, 2, 3, 4, 5. That's a vector of integers from 1 to 5. And I assign this to my xvec. So as you can see, this is a 5-element vector. And then you get that curly brackets. So anytime that you see a curly brackets in Julia, your spiner sense should be triggering and say, okay, this is a container. This is a collection. This is something that holds elements inside. So this is not a primitive type, like we say. So that's the idea behind the curly brackets. So as you can see, this is a vector. And the type that the vector holds is a vector that holds elements of type int64. So that's how we read these curly brackets. Every time you get a curly bracket, it's something saying that this is a container type, and the type of the container is the thing inside the curly brackets. So that's if you do type of xvec, you see that the type of our x vector is a vector of int64, and it's pretty much like a shorthand notation or an alias for array of certain type int64 with number of dimensions 1. So if you have a one-dimensional array, that means a vector. So that's why we have this nice vector notation. We also have matrix. So if we do something like X matrix, I don't know if you have time to cover matrix today, but matrix, we do have a different syntax. So I'm going to put 1, 2, 3. I'm not using commas here. And the next line, I use a semicolon, and I do 4, 5, 6. So this should translate in a 2 by 3 matrix. 2 rows, 3 columns, 1, 2, 3, 4, 5, 6. And as you can see, this is a matrix of type int64. And if I do type of X matrix, I get back. This is a matrix. So I have the curly brackets. This means that this is a container type, and the underlying type inside that container is of integer 64, int64, and also this thing here is an alias, a shorthand notation for array of certain type with dimensionality of 2. So a 2-dimensional array is a matrix. So it's arrays all the way down. So as you can see, vector and matrix, they pretty much get compiled or gets represented down as arrays of a certain type with a certain n in dimensionality. So we can have like tensors. If you go over higher than 2 dimensions, pretty much it works. One more thing. So what if I create like another vector, but this vector I have one, a string, a boolean, and a float. So this vector will be a 4-element vector of any. So the underlying type of this vector is any, and as you get more familiar with the Julia community and the Julia type of things, how we do things here, we don't do that because it's not performant. So you are going to pay a lot of performance penalties if you leave your vectors with a type that is any, because Julia cannot be efficient in allocating memory and doesn't know what to do with this, because you can pretty much stick anything inside this vector. So having vectors of type any will not be the best habit to create. So always make your vectors single type, if possible. And this also works with matrix. So that's pretty much everything about types in Julia to get you started. We know we have abstract and concrete types. Abstract types we cannot instantiate. They represent collections of, they represent sets of concrete types. Concrete types we can instantiate. We can create variables and objects. We can do supertypes, supertype, and subtypes, helper functions to inspect the types that we cross in our Julia coding. So whenever you cross paths with a type that you've never seen before, inspect it with supertypes and subtypes. And you can also do is-a comparison. And is-a is just a function, so you can do is-a y real, that also works. So this is a function, but you can also use this as an operator. But Julia will pretty much parse this and convert this into this function call here. But you can use that as an operator. To get the size of things, you can do base.summary size. So this function is not exported by default into your current environment. So you need to access the base model and then the dot and the function, because this function is not exported. You can also test if a type is concrete or abstract. And we can create vectors and matrix and any type of arrays. And whenever you see a curly brackets, you should be pretty much familiar that this is a kind of a container. And the thing inside the curly brackets is the underlying type of the elements of that container. So that's the idea here. Let me see if we have some questions. So we have a question. I pretty much don't know how to answer. Is abstract type? I don't think we have that function. Is abstract type? So do we have it? No, we don't have it. So the only implementation is this one here. We don't have the camel case implementation. What is meant by abstract array type? Okay, so take a look at this vector here. So xvec. If I do a type of xvec, you see that this is a vector of integer 64. So this is a vector. So xvec is a vector type, and the underlying underlying type of the elements that it holds is of type int64. That's what we mean with container. And I don't know if the container is the technical term. It's just a type. We call that compositive types. It's just a type that, not compositive type, sorry. It's a type that holds other types. That's pretty much it. You cannot do that with the primitive types like integer, floats, booleans, and strings. So they are a primitive type. So that's what I mean with containers. It's not the most precise technical definition, but it's pretty much intuitive, and this is the idea in this introduction to Julia. What is meant by abstract array of type? We are going to cover this in the functions. So you can pretty much create a function that will operate on an abstract array of a certain type, like abstract float. True. So this, if we say that in a function signature, we will be expecting any kind of array that has any kind of floats, but arrays with dimensionality equals 2. So that's matrix. So that's what we meant by abstract array. And we have some packages that extend the array. So we have something in the Julia standard library. We do have sparse arrays. So we have sparse matrix. We also have a package called static arrays. I think this is how, it's not in my environment, but we have static arrays, which is a faster implementation. And all of those, they will implement subtypes of the abstract array, abstract vector, and abstract matrix types. So if you want your function, or if you want your code to function with all of the subtypes of all of the different types of vectors, you can do that. So that's why we have also abstract types for the collection types. That's the idea. Oh, we do have a lot of questions. So one last questions before we move forward. Okay, no. Okay, let's do more questions. We do have a lot of questions. So is variable type string the same as vector char? No, it's not the same. A vector in Julia, it's pretty much a collection of objects. So if you want to create like a vector of characters, you can do so with something like this. So as you can see, this is a 2-element vector of char. And the same if you convert those to strings. So if you do something like this, you get back a 2-element vector of string. So in some languages, especially the typed ones, the compiled ones like C, C++, and Rust, you get that representation that string is a vector of chars, but not precisely here. You can index a string, so you can get something like my string, which we already defined it. So welcome to JuliaCon. I can get the first element and I get the W. So that's welcome. We can also index strings if we need, but they are not the same as vector of chars. Is container the same as list in Python? Not exactly. So in Python, a list, you don't have the underlying type. In Julia, if you create a vector like 1, 2, 3, 4, 5, this vector, it has a type. It's an integer 64, and I cannot add once I instantiate this x. So if I try to push, and we are going to showcase this in a minute. If I want to try to push, I always forget. It's push. There you go. Push. I always forget. It's first the collect. So if I want to push like to include a new element in my vector x with the value 6, it gets implicitly converted to an integer. Or if we try to do it push a string, we'll get an error. And as you can see, we get a method error. I cannot convert an object of type string to a type of integer because you are trying to push to include a string type into a vector of integers. So if I cannot convert it, it throws an error. So Python, it doesn't have that. And this is why Julia is much faster than Python, because Julia asserts that things are fast by making things what we call type stable. But that's a little bit more advanced topic. Not for today. Types implemented as classes? No. Types are types. Julia is not an object-oriented language. We don't have classes. We have structs that we probably will cover in the last minutes of this workshop. So stay tuned. We'll discuss structs in a bit. Is there any efficient data structure for this in Julia? Almost all data structures in Julia are efficient because Julia is it was created with efficiency and speed in mind. So you need to make some effort to make Julia slow. But go ahead. There is a section in performance in the Julia documentation. Take a look on that. And there are some things that you need to do to make sure that Julia is always top-notch in performance while executing your code. Okay, I don't see any more questions in Pigeonhole, so let's move forward once more. So we are going to start now with the if, else if, and else. This is the control flow statements as they are known in other languages. And also Julia, they are called control flow. So in Python, for example, you have something like if something, and then you have the column, and you need the indentation. So that's how you do in Python. In Julia, it's the if, and as you can see, there is a tooltip in VS Code, and if I click or select this tooltip, it will auto-complete the if statement for me. So we pretty much put if and then the expression that we want to be evaluate. This expression needs to return a Boolean. So it needs to be evaluated as either true or false. So if I say something like, let's say, if 5 greater than 2, then I go to the next thing. let's say print line 5 greater than 2. As you can see, Julia, we have the if statement and all of those special statements that I'm going to start presenting now. The if, else if, the for loops, the while loops, the functions, they need to be followed by an and statement. So if I start with the if statement, I need to end with the and statement. So this pretty much will evaluate, and this thing will evaluate to true, so it will execute this code here, otherwise it won't. So if I switch, say if 5 less than 2, so that will evaluate to false, we get nothing. So nothing is printed. And Julia is not sensitive to indentation. It's just that a convention for you to indent your if and other blocks. Whenever you see an and, a block that starts with a keyword argument and has an and keyword argument, to tell Julia that the statement has ended, you will indent by either 2 or 4 spaces, depending on which you prefer. Most of the time is 4 spaces, but Julia is it's not sensitive to indentation. So if I pretty much indent, so if I remove the 4 spaces from my if statement and I run this, it works. But to make it easier for the eyes and for us to see the code, we generally indent by 4 spaces. That's how I do it. But Julia doesn't need that. It needs the end here. So the end here, if I remove this end, we get an error. So incomplete syntax. So we get premature or end of input. So that's what we get when we don't put the end statement. So that's a single if. We can have an else. So we can do if 5 higher than 2. Let me copy this. As I said, I'm lazy. So print line else print 5 is lower than or equal to 2, something like this. So as you can see, for the if and if else statements, we just need one and keyword. We don't need 2. So we pretty much put the if, and then we add the else, and we end it with the and keyword. So this expression here will be evaluated. If true, it will run this code. Otherwise, it will run this code here. So this will pretty much print the line 10. So 5 is greater than 2. Now, if we change signs, it will print the thing inside. It will evaluate the code inside the else block. Oops. And there you go. We get it evaluated. So that's how we chain if with an else statement. We also have if, else if, and else. So in Python, you would have something like if something that you indent, then you do elif. Other thing, you indent, and then you do it else, and you would indent your expression. In Julia, you pretty much do an if. So let's say, let's copy. Let's make a variable, okay, x. So x equals 5. So if x is higher than 2, we are going to print line x higher than 2. Else if x lower than 2, we are going to print line x lower than 2. And we put an else statement. string line. So it's if it's not higher or lower, it's equal. So x is equal to 2. And then we end with the end statement. So we can pretty much chain how many else ifs. So I can do something like else if x equals 0, x is equal to 0. And I can pretty much chain how many else if statements I want. They just need to be sandwiched between the if and the else. So let's run the first line of code to assign our variable x with the value 5. Then we run this. As you can see, x is higher than 2. And if we change this to 2, we get x is equal to 2. Because then it evaluated all of those if and else ifs. All of those were evaluated to false. Hence, the only thing that was left is print to execute the code in the else block. So that's how we do if, else if statements in Julia. It's pretty much easy and very familiar to other languages. So that's something easy. Now let's do, we have some questions. And before I answer the questions, I have some exercise for you to do it in the 5-minute break. And let's answer, there is one new questions. Why isn't else if shortened to elif in Python? Because it's a design choice. I prefer else if because elif, it's a little bit ambiguous. So I prefer else if. That's my personal opinion, but as Homer Simpson would say, it was already this when I arrived. So it was like this when I arrived. So it was a design choice long before my Julia days. So that's how the language was made. Okay, so let's go into a 5-minute break. We'll be back in 5 minutes, and there is some nice exercise here for you if you want to try it on. So we have 2 exercises. They are in the GitHub repo. There are some solutions also, but if you want if you are stuck, you can see the solutions. But try to make those exercises and see you guys in 5 minutes. Okay, and we are back. Let's wait for everyone to get back. I think we are done with our 5-minute break. Sorry about that. Let me see if we have more questions. No, we don't. So let me showcase how I would solve this exercise. Just a caveat, exercise is like a mountain. You want to go to the top. There is not only a single way, there are multiple ways. So the way that I'm solving might not be the only way or the most efficient way, but it's a way to the top. So we get a number. So this number I already asked Julia to generate a random number between 1 and 100. And it's 9. So let's test if a number is a multiple of 3, 5, or 7. How I would do it is I would use the modulus operator in Julia. So if number mod 3 is equal to 0, that means that if I divided this number by 3, if I get back, if the remainder is 0, that is pretty much what is testing. It's the modulus of operator that you see a lot in algebra. So if number is modulus 3 equals 0, this will evaluate to a true statement or false. So that's the most important thing in an if, else if, and else block. You need your statements to be evaluated to either true or false. So if number modulus 3, mod 3 is equal to 0, that means that the number is divisible by 3. So the number is divisible by 3. And we pretty much chain an else if. So as else if number modulus mod 5 equals 0. I'm gonna copy this line here. This means that the number is divisible by 5. And we put another else if number mod 7 equals 0. That means that our number is divisible by 7. Else, just print that the number is not divisible by 3, 5, or 7. There you go. And of course, we need to end it with the end statement. Let me just close the door 1 second. Okay. And if we run this block of code here, if we run all of this, we get back that the number is not divisible because I asked it to generate another number. So let me see, 69. So let's run this. Yeah, 69 is divisible by 3. So that's how I do it. Second exercise. Oh, this is nice. So this is a geometry question. We have the Cartesian plane and we have the quadrants of the plane. So we have the quadrant 1. That's pretty much if the points are positive. So we can do something like this. So here I'm generating 2 random numbers between minus 1.0 and 1.0 with step size of 0, 1. So this will generate everything from minus 1.0, minus 0.9, 0.8, so on until 1. So that's how we do intervals in Julia. That's how we do it. It's much more intuitive than Python, I think. I'm always adding plus to my Python scripts because I don't know how to do zero index. So this will generate 2 random numbers, and I'm going to unpack those numbers into x and y because this will generate 2 numbers, and I'm going to assign those to x and y. So there you go. We have 0.5. Oh, sorry, I need to remove the break, yes. Oops. There you go. Thank you. Yeah, I forgot that. Thank you for letting me know. So here how we do it. So if x is higher than 0 and that's a Boolean statement, and y is higher than 0, that means that both of them are positive and the point is in the first quadrant of the Cartesian plane. So I'm gonna print line x and y are in the first quadrant of the Cartesian plane. There you go. I'm gonna copy this line. And else if, so if x is less than 0, so if x is negative, and y is positive, that means that our point is in the second quadrant. Now we are going to do another else if x is negative and y is positive. Oops, y is negative. Oh, then we are in the third else if, or you can do just an else, but no, you cannot do an else because there is a corner case. So we do else if x is less than x is higher than 0 and y is less than 0. It's on the fourth quadrant. Else, okay, if our point is in any of those, then of course our are at the origin, so it's 0, 0, the point. So that's how we do it. And as you can see, it's in the fourth quadrant of the Cartesian plane. That's the idea here. So let's move to the for loops in Julia. So let's save this. There we go. So how do we do a for loop in Julia? It's pretty much the same as in if. We start with the keyword argument for, and when we type this, VS Code already does nice tooltip for us. So for, and it pretty much auto completes for us. So for something in an iterable, so something that you can iterate, so we can do I or number in let's do 1, 2, 3, 4, 5. So for every number in 1, 2, 3, 4, 5, you can do something like print our number. Now, if we execute this, we get back we get printed our numbers in the collection. So it's pretty much how we do it. You can also do it with intervals. That's what we call in Julia. So you can do something for n in 1 to 10. You can also ask to print can also add to print the number. So this will print all the numbers from 1 to 10. We can also do something like 1 to 10. So this will increase the step size to 2. So we can do 1, 3, 5, 7, 9. The next one would be 11, but 11 is greater than our upper bound of 10. So that's why we don't get an 11 back here. And yes, I forgot something about this exercise about the axis. Yes, someone actually noted that. Yes. So you need to fix this if else statement to account for the cases that your number could be in an axis. So maybe add greater than equals in those will fix that. And or you can do something like this. Yes, that's at the origin of the or at one of the axes. And if it's on both of axes, so it's in the origin. So I guess that's it. Good point. Thanks for the correction. So it's really easy how to do for loops in Julia. You can also do something like n equals I don't know. Oh, there's one nice thing in Julia is that you can C++ has that. So in C++ you can do something like this. It's 1,000. So in Julia you do underscore. So if you have like big numbers like this, you can pretty much do something like 4 n in 1 every 100,000 until my big N. Oops, my big N, you are going to if. Then you can put if inside and that kind of thing. So you can do pretty much like print line N. Oop, and then you can run this for loop and it will print all of those. Of course, we need to do 0, maybe. And this will print our 100,000. So 0, 100,000, 200,000, and so on. So we can do this kind of thing. So the syntax is start, step, finish. So you do something like start at 1, the step size is 3, and finish at 20. So this is the syntax. That's the syntax. And if you, of course, by default, if you do not put any step, it defaults by 1. So it will go in increments of 1. That's the idea. But for loops is pretty much easy in Julia. And also Julia is 1 indexed, so it's not 0 index. So it's a little bit intuitive because if you want to go from 1 to 220, you want to include the 20. And you can do more stuff in intervals. Go to the documentation at julialang.docs.julialang.org. So there you see the documentation. Also, Julia we indent the for loops just for a better visual representation to make code more readable, but we don't need to indent those. We just need to have the and statement here. So 1, 2, 3, 4, 5. I left some exercise here. I'm gonna leave you guys to do it in the next break, and maybe we'll cover those if we have time. I need to cover more stuff, so I won't be doing those exercises because we are running out of time a little bit. Let me see if we have questions. Ooh, we have questions. Do Julia use parentheses? Yes, we do. So, is this font size better? So the rand syntax, it's a little bit, it's not simple because it's a function that you can call it with different arguments. That's what we call multiple dispatch. It's one of the main features of Julia. So as you can see, there is 160 ways that I can call rand, and we are going to cover multiple dispatch in a bit, and I will showcase the rand for you. Okay. What is the difference between print line and print line, print ln? So Oscar pretty much already replied for me. Thank you, Oscar. So print line puts a new line after the thing that is printed, and print does not. So for example, let me showcase that with this for loop here. If I do print, you see I get 1, 2, 3, 4, I get 20. So I'm printing stuff in the terminal without adding a new line. So print line is the same. So if I do something like this, so now I get print line. I'm pretty much doing string interpolation here, pretty much like an F string in Python, and I'm adding the new line character here. So this it's what print line is doing. So print line will print every time that it prints, it will add a new line. So that's how print line is doing. Can you comment on the speed of the for loops in Julia compared to those in Python and C++? Python is faster, and depending on your Julia code, it can be faster than C++, depending. There is a nice case study of some algorithms that a colleague at the Institute of Spatial Research here in Brazil, he was trying to translate some Julia stuff into C++, and with the help of the community, he benchmarked, and Julia algorithms were faster than the C++, and those were very some of those had a lot of for loops, but faster than Python, yes, definitely. Faster than C++ could be, depending on the context, because Julia uses LLVM to do a intermediate representation of your code, and it exposes that to the compiler, and the compiler in some cases can optimize better the code even when comparing to C++ optimized code. So I'll leave that to the compiler guys and the speed guys. So take a look at the conference schedule and go to those workshops, to those talks that you see a lot about compiler and performance in Julia. How long does it take to learn Julia for basic operations? A little bit. I mean, this workshop is already covering like I mean like almost everything that you need to know to get started with Julia. For you to migrate fully, just a little bit, and you are ready to go. So let's move on. Let's go to our while loop. So this is going to be a really brief one. While loop, it's pretty much the same as you saw in the if and the for loops. So you pretty much put something like, okay, let's define an n here, 10. So this is what I'm doing. Don't do it because it's not performant, but I'm gonna do it just for the sake of showing you guys. So while n less than, let's do n equals 1. So while n less than 5, you are going to print line n, and you are going to increment n by 1. This is not performant because n is outside the scope of the while loop, so it's in the global scope, and using global variables is not good, but just to showcase you guys. So as you can see, it keeps repeating this loop until the condition is turned false. So every time it goes here, it will evaluate this. If it's true, it will execute this code block. If it's not true, it will carry on. So that's how while loops works in Julia. We do have some exercise here. Print all natural numbers from 1 to n, and print all natural numbers from 1 to n in reverse, and also print all natural numbers from 1 to n, even numbers from 1 to n. So pretty much those exercises starts with a random number called n that is between 10 and 50. Just to get. How would you put n in the loop to avoid global variable? That's a good question. You could do some things, but in Julia 1.8 or 1.9 in the next or the following Julia release, you could annotate your global variables. You could say something, okay, this is an int 64. You could do this, but as you can see, there is an error here. Type declarations on global variables are not yet supported. They will be, but they are not yet supported. You can use a function. That's pretty much it. You put inside a function, and there you go. And type globals are in 1.8. That's it. So pretty much we are already in the release candidate 3. So 1.8 release candidate number 3. So 1.8 might be just around the corner right after JuliaCon. I don't know. I'm not a Julia developer, but might be. Okay? But that's how you would solve it. And thanks, Oscar. So that's how we do while loops. Let's see questions. We don't have any questions. Okay, let's move to the functions then. And this is where we are going to spend a little time. Because this is, Julia is a language that uses heavily functions. And we are going to showcase some multiple dispatch examples here. So functions, how we define a function in Julia is pretty much the same as we did in the for loops, the while loops. We start with a keyword argument that's function. We say the function name. We open and close back brackets. Any arguments that the function takes will be inside those arguments. And here we do stuff inside the function. So this is the body of the function as it's called inside the function. So this is the body of the function. And we end with the end statement. So that's how we define a function. And there you go. We have a function. It's already defined. And if we go here to our Julia extension, and you go down here, you see that we have a function name here in our workspace. So you see that we have a function name here. It's in our workspace, and we can close this thing here. And you see that function was defined. It's a generic function with one method. And we will get back to this method and functions this distinction in a bit. But that's how we define functions. And if we call this function, it pretty much returns nothing, because by default, if we don't do anything, the function will return nothing. There is so if we do type of the return of the function, when we call the function, it's nothing. So that's pretty much what the function returns. So this is the long form, the default form, but we also have the short form. We can do something like short function equals nothing. So we can also define a function like this. So sometimes you see this in Julia scripts when the function is very short, that to make function, the function name, the arguments, and then everything, and then the end, it's cumbersome. Developers will switch to the short form assignment. So, and if we go into the short function, it returns nothing. And if we do type of short function, it's nothing. So we can also do something like short function returns, I don't know, returns short function. So we can also do this. And if we call the short function, we get back a string. So that's like compact form assignment. We do have some things in the chat. No, that's not a lambda. Lambda is an anonymous function. We are going to cover this in a bit. This is just a compact function assignment. But this, if I do type of short function, it exists. It exists, and it's a singleton type, so it exists. Anonymous functions, it's just reference. I'm gonna cover anonymous functions in a bit, but this is just a function defined using the short form assignment. So let's start. We also can do something like function. So function name, and then we can say so return function, and then we can end. In Julia, we generally use the return statements to indicate that our function is done, and we want to return whatever value we want to return. So this could be either a string like I'm doing here, or we can do something like x equals function, and we can do return x. So this also works. So if I call function name, we get back a string called function. So that's how we assign functions in Julia. That's how we do it. As always, we just indent the functions, the keyword arguments that needs to be followed by an AND statement. We indent those with 4 spaces, but you don't need that because Julia is not sensitive to indentation. It's just for us humans to understand and read the code better. But this also works, and functions, okay. But by convenience, we indent our blocks inside a keyword argument that needs to be followed by an AND keyword. Now let's cover, let's see if I have questions in the pigeonhole. No, my short function is not a lambda. We already covered that. Thanks for the question. So position arguments versus keyword arguments. So in Julia, we have position arguments and we have keyword arguments like every other language, but we have a distinction between those. So let's create a new function. So this is a function, let's call function 1, and this takes an x and a y, and it returns, oh, let's do sum 2 numbers. There you go. Return x plus y, and then end. So if we run this, and we call sum 2 numbers with 3 and 4, we get back a 7. So this function, it takes 2 positional arguments. That's the idea. Now, let's add keyword arguments. So I'm going to create a new function called sum 2 numbers with caveats. It's going to take x and y as positional arguments, but I'm going to add a semicolon. This semicolon states to Julia, okay, Julia, I'm done with positional arguments. I'm going to start my keyword arguments from now on. So there are 2 positional arguments, and now I'm going to start with the keyword arguments. I'm going to start with the keyword argument 1. This has a default value of, let's do 1. And also, I'm going to start with the keyword 2, and this has a default value of 2. And this is going to return the sum the sum of x, y, q1, keyword argument 1, keyword argument 2, and end. So if I do sum two numbers with caveats and I pass in 4 and 3, we will probably get back a 10. Oops. Oh, I need to convert those to... Okay. It's been a while since... So it's a vector. Okay, so let's do a vector here. There you go. Now it returns a 10. Don't be scared about errors. As you see, I get tons of errors. So as you can see, I just provided the two positional arguments, and if I do not specify the keyword arguments, they will take on the default values. Now, if I just try to run this function with one keyword argument, you see that I got this blue squiggle line. It's saying to me that there's a method call. So there is no method. There is no method matching this function, which takes integer 64. The closed candidates are sum that takes two positional arguments and two keyword arguments. And it's defined at, in this file here, line 25. So that's the whole stack trace. Of course, the positional argument, I need to... The ordering matters, but the keyword arguments, the ordering doesn't matter. So key 2 equals 10, and key 1 equals 5. This is going to turn out 22. This will work because the positional arguments I can specify in any ordering that I want. So that's the difference between keyword argument and positional arguments. Keyword arguments can be anything. So I'm going to explain this a little bit. I'm going to, let's say I have a function. This function is called round number, and it takes an x. Now I'm going to give the type to that x. So this x is a float 64, and this returns round of x. So that's it. So that's my round number. It takes only one positional argument, and this positional argument is of a type float 64. If I call round number in 3.14, for example, a float, it will round to the nearest integer, and that is 3. And we can also do int 64 of this one thing. So then there you go. It rounds that to it rounds and convert that to an integer 64. Now, what happens if I try to call this with an integer, with 3? I get an error. I get a method error. There is no method, no function signature, round number that takes a positional argument as integer. The closest candidate is round number that takes one positional argument as float, and it's defined in this file here, line 34. So that's what the stack trace is telling me. So if you want, you can define a custom behavior. So let's define a function round number that takes an x as integer 64 and just returns x because it's a no-op. So now I get a function round number. It is a generic function. It now has two methods. We have the round number that takes one positional argument as float and one positional argument as integer, both of them being 64 bits. So that's a single dispatch. So this is custom behavior based in one type based on the type of one argument. And this, I think C++ can do it, and other languages can also do it. But we have something called multiple dispatch. So multiple dispatch is something that is, I don't know if it's unique to Julia, but it's pretty much something that Julia is notoriously known for. Multiple dispatch is you define custom behavior based on 2 or more argument types. So for example, if you are doing machine learning, you can have a custom training loop, and you can have a train function that gets called that does custom behavior depending on the type of arguments that you are calling it. So this is something really powerful, and this, coupled with what we are going to be covering in the next half hour, which are structs, is what makes Julia so powerful and what makes Julia expressive and also composable. So you can compose different packages with each other, and things works and they work pretty much fast and flawlessly. You don't have to create like APIs for everything. So for example, in PyTorch, if the thing doesn't exist in the world of PyTorch, PyTorch doesn't know how to deal with that. And if you go to Flux, which is the Julia deep learning stack or package, you can pretty much create new stuff without much effort, just because you have multiple dispatch. So let me answer some questions, and I'm going to give some examples of multiple dispatch. Okay, let me see. We have 3 questions. Can you supply a value of the X parameter by name, treating the position argument as a keyword argument? No. Position arguments are position arguments. Keyword arguments are keyword arguments. So you pretty much have to put the keyword arguments after the positional arguments. You can do it with a comma here, but I prefer to be a little bit more verbose and explicit and use a keyword argument, as most of the Julia users like that, because this clearly states that we are done with positional arguments and we are now starting with keyword arguments. When you call the function, so this works, but if you try to define, so let me copy this. So I'm gonna call this function a function sum to number with caveats number 2, okay? Because I want that to be another function. So if I remove the semicolon, pretty much I'm telling Julia that this function, it has 4 positional arguments because there is no semicolon. And the third and fourth positional arguments, they have custom values. So if the user do not specify those, the custom values will be there. So if I define this, and if I call this like this, it works. But if we call this like this, oops, sorry. This shouldn't work. Let me see. There you go. There you go. So those positional arguments, they are not keyword arguments. So we cannot do keyword argument equals that. We can only do this because they are positional arguments. Or we can do maybe this, or we can do maybe this. But we cannot do it keyword arguments. So that's the difference between them. I think that answered your question. Let me see. Other questions? Does Julia have optional position arguments and required position keyword arguments? Yes, it does. If you don't specify a value, it's required. So if I do let me do function with caveats number 3. Okay, let me do number 3. So if I do something like Q1 and Q2, so Q1 doesn't have a default value, so it's required. Q2 has a default value, so it's not required, it's optional. Now, if I do this, and I call with just the positional arguments, I get an error because I need to define Q1, the keyword argument. So I need to do Q1, oops. I need to do Q1 equals 3. Now this works. And you can do the same with the positional arguments. Any of the positional or keyword arguments, if they don't have an equal sign, that means that they don't have a default value and they are required for the function to be called. Is there a hierarchy which function is used when there is a multiple dispatch case? Yes, there is a hierarchy. It will use the closest one. So if you have something like, okay, let's play around. Okay, so I have function fun1, and this function takes an abstract float. Okay, this will return abstract float, and we get a function fun1 also that takes float 64. This will return float 64 end. So if we run this, we get that our fun1 is a generic function with 2 methods, and if we call this with a 2.0, we get back float 64. If we convert this 2.0 to a float 32, we get back an abstract float. So that's the idea. So by default, it will match with the most similar. So since we don't have a float 32 custom method for the fun1, it will default in the abstract float. So that's the idea. How to specify only keyword arguments? Oh, that's easy. So let's go down here. So function with keyword arguments only. Q1 equal 1, Q2 equals 2, and then return P1 plus Q2, and I need to make this one, and let's do another. And so there you go. And if we call our quark only function, it works. That's how you do it. That's easy. You have 0 position arguments, then you put a semicolon. Okay, I'm done with position arguments. There are none. Now we are going to supply you with the keyword arguments. That's the idea. I think I answered all of the questions in Pigeonhole. So let's give an example of multiple dispatch. Oh boy, I'm a little bit fried with examples, so let's do a very simple one. Let's do sum two numbers. So if you have x as any integer and y as any abstract float, this will return x plus round int 64, or just, I think int. Can I do int? Maybe int y. So this, let me try this. So sum two numbers. So let's do 1 and 2.0. Yeah, it works. It will, by default, it will default to my system. So it's 64 bits. So I'm running Julia in a Linux 64 bits. Now we can do function, some two numbers, which take X positional arguments. It's abstract float, so any float, and Y is an integer. So this will return X plus, let's do float, lowercase, Y, and end. So now, if we do it the opposite way, we get 3. So that's a basic example of multiple dispatch. Very basic example. And this is much more powerful if we start to create like custom user-defined types that we are going to see in the next part. I think I should have made a break, but what about we go a little bit, because I'm worried about the time here. We have only 25 minutes, and maybe we can end like 2 minutes earlier. Let's see if we have any questions. No. So this is a basic example of multiple dispatch. So we have a function. It's one function. It has 3 methods. By default, Julia defines a method with any for us. If we define an specialized version of the function. So it's a function with 3 function signatures that does custom behavior based on 2 or more types of arguments that's being supplied. That's the idea. Let's go over anonymous functions. So how do I do anonymous functions? Anonymous functions in Julia, it's pretty much like you do in math. So x maps to x plus 1. That's sorry about that. That's an anonymous function. Now, if we make this in parentheses, if we wrap this anonymous function in parentheses, we get back a generic function. That's our anonymous function, and we can pretty much call this as a function in the number 5. So that returns a 6. So that's our anonymous function. We can also do stuff like x. So is odd x. So this is a test. If x is odd, and I call this in the number 5, this returns true. So this is an anonymous function. And we use this function when we are doing filtering, for example. So suppose I have a filter. So filter, then I get a function. This can be an anonymous function. So I can do something like x higher than 3. And the second argument of the filter function is the collection or a vector of numbers. So I can do 1, 2, 3, 4, 5, 6, 7, 8. Oh, I already taught you guys intervals. Okay, so let's do intervals. It's easier. 1 to 10. So then we get back a 7-element vector. So that's how we use it here. We put an anonymous function here. We can also do the same with a function. So we can say something like is odd. So this function, I don't need to call it in an anonymous fashion because it only takes 1 position argument. So I can pretty much put the function here. Julia will know how to do it. There you go. Or if you want, you can also make this is odd x. So it's also the same. And as someone just noticed, yeah, this is much more mathy. So if you like math textbooks notation, this is much better than the lambda x or the function x that you have in R and Python. I think it's much more intuitive. So Julia is, like I said in the beginning, my opinion, Julia is one of the best, or the best scientific programming language in currently. So if you're doing scientific programming, you probably are a mathy person or a science person. So you do enjoy this kind of notation. You do enjoy having the pi constant in Unicode for you. So that's one thing. Let me see if we have questions. No questions. So that's how you do an anonymous function. I have some function exercise here for you guys. So you can play around. It's in the GitHub repo. There are some solutions. As I said, my solution might be not the best or the most efficient one, but it's the most beginner-friendly solution for you. So any questions about functions? And we can move to the last topic, which is user-defined user-defined types. That's structs in Julia. Okay, we have one question, Pigeonhole. Can you repost the code repository? Yes. So it's this one. There you go. Actually, I posted the whole thing. Sorry about that. I posted a link to a file, but it's in that repo. So let's talk about custom-defined, user-defined types. So Julia is not an object-oriented language. It's not OOP. It's a language that it's hard to describe with one word, but it's a language that you don't have classes. That's easy to define like this. So we do have user-defined types. These are called structs, and they have that name because they are structures, and those familiar with C or C++, you know what structs are. I think they are in other languages also. So how we define a struct? We call the struct keyword, and we call the name of the struct. So this is a type, so I'm gonna use a title case. So I'm gonna call this my struct. And as every thing in Julia that I'm using a keyword argument, I need to end with the end statement. And inside the struct, I list what we called fields. So things that are inside the struct. So let's say here name and age, for example. So this is my struct. And it has two fields, so name and age. So if I want to instantiate a struct, I pretty much put my struct. So let me instantiate myself, so Joseph. So I am, or let's call this a person, it's better. So let's call this is struct person. So Joseph is a person. Now I need to use a constructor. I'm not gonna cover custom constructors. You can do that inside your struct. I'm gonna just cover the default constructor. By default, Julia creates for us a constructor of this struct of this user-defined type. And it's pretty much a function name with the same name in title case also as the struct. So it's a person, open and close brackets, and we need to pass the fields as position arguments. So the first, it's name, so it's Joseph, and the second is age, so it's 34. 34, yeah, 34. So that's it. And as you can see, we have our struct José here. It's if we do type of José, you see that it's a person type, and also we can access the fields. If we hit José dot, you see that VS Code is suggesting us that we can access any of the two fields, age or name. So if we do José.age, it will return an integer, that's my age. If we do José.name, it will return a string, my first name. Also, by default, the structs, they have fields, which I can query with the field fields function. So if it accepts a struct. So if I do person field, oh, it's field names. Sorry about that. Field names. I get back the field names. I get back as a symbol. That's this column thing. So we have name and age. That's my field names. I can also have field types. So let's copy this. I can also have field types. And as you can see, if I don't give a type to the fields, by default, they will have type any. How do I fix that? Pretty much like I did in Julia, in functions. I use the double semicolon to annotate, not annotate, because it's much more than annotate. Because Python, you can annotate, but it's pretty much like IOU. It's okay, I promise that this will be a type, but in Julia, it will error. So if you annotate a type inside a struct or a function, pretty much it will error if the type cannot be converted to the type that you said that the field or argument is. So I can put here, okay, name, it's a string, and age, it's an integer 64. So let's redefine our struct. Oh, invalid redefinition. I forgot about that. So let's give our session and let's start a new one. So now it will work. And there you go, we run. And if we do José, as you can see, we get back, it works. But if I do José with, I don't know, true, a Boolean type as the first position argument, which is the name in our constructor, this will give an error. So cannot convert an object of type bool to a string. So pretty much the stack trace tells us that the constructor for the person takes two position arguments, name and age. And name, you call name with the Boolean and you called age with the string. So that's pretty much it. We cannot convert Boolean to a string. If you take a look at the person struct, you see that it's an struct and it has those fields. So Julia automatically generates a help documentation for our user-defined types that are structs. So as you can see, we have our fields, and name has to be a string and age has to be an integer. Otherwise, it will not instantiate your object of type person. So that's one nice thing about Julia. And we can also see the field names. As you see, it's age and person. But now the field types, it's a string and integer 64. So let me see if I have questions. No questions. So that's how we define structs. One caveat with structs is that they are immutable by default. So Julia is a performance-oriented language. So almost all things will be immutable by default. So structs are immutable by default. So if you try to, for example, if you try to get a José name equals, I don't know, you put something with my real name, which has this funky E, because it's Portuguese, you see that you get an error. And the error is, it's because Julia calls the setField bang function. And under the hood, when you are trying to redefine a field, you are trying to do the setField, immutable struct of type person cannot be changed. So if you create a struct, it's immutable by default. You can have mutable structs though. Bear in mind that mutable structs, they are not as performant as immutable structs. You get a small performance hit. But if you need to change field values in your structs, once they are instantiated, you definitely need a mutable struct. So the way you do it is pretty easy. You do mutable is struct. There you go. So let's do mutable person. This is a new struct. And it's going to have also name. It's a string, and age, it's an integer 64. Now I can instantiate José mutable. It's a mutable person. My name is and my age is 34. There you go. And if I need to change something, I can do it. So José mutable name equals, so let's correct this to the Portuguese, is this. And if I do José, if I type it right, okay, José mutable, you see that it's a mutable person with these two fields. José, now change it, and my age. I can also change my age, so the whole struct is mutable. So, oops, 34. There you go. And now let's add one, 35. And as you can see, José now has a birthday, and he's 35. Let's see questions. Examples of practical use for struct. Yes, I'm gonna give you an example. It's one of my favorites. It's from JuliaCon, I think 2018 or 19, from Stefan Karpinski. I don't think I'll have time to give the whole example, but I can kind of do it. I'm not using too many extensions. This is the basic default dark theme. And Julia, I'm just using the Julia extension. The Julia format that I haven't even called yet. The other ones are just other extensions. So to get these, you just need Julia and dark theme for VS Code. That's it. Julia does all that. So we can also have abstract types. We can define abstract types in Julia. The way we do it is so Florian just asked, can a structure contain a function? No. The only function that you can have in the struct is a custom constructor that you find in the Julia Lang documentation. But if you want a function, you pretty much define a function that takes your, okay, let's see, a function newborn. Okay, this function newborn, so let's move over. It takes an x, that's a person, that's actually a mutable person. And it pretty much does x, so this is a function that will alter our struct. So I'm gonna add the bank. There's a notation in Julia, that convention in Julia, that functions that change one or more of its arguments must have a bank prepended in the name. So I pretty much do x age equals 0. So this function makes a mutable person becomes a newborn. So I define this function, and I can do newborn in José and José mutable. Sorry about that. And now, as you can see, José mutable is a baby. It has 0 as age. So that's how you do it. Functions in that operates on your custom user-defined types, the structs. That's how you do it. Now, one last thing. I have 5 minutes, so it's abstract types. So we can define abstract types. We cannot instantiate abstract types, so we can do something like abstract type pet end. So we created an abstract type pet end. Now we can create two structs. You can do struct. Let's do dog. And we are going to use this thing here. I think it's this. I always forget this. Yeah. So what this is the subtype operator. So I'm defining a struct that is a subtype of something. And I'm defining a structure dog that is a subtype of pet. And end. So there you go. No fields. And I'm going to define a struct called cat subtype of pet and end. Now I can create a function called encounter. If I have two pets, X and Y, this returns, I don't know, fallback, okay? Because it's just on the abstract type. Now I can create also a new function called function encounter. Come on. Okay, encounter. Now if a dog encounters a cat, return. Oh, there's a chase. There you go. Now I create a new one function. Encounter X. A cat encounters a dog. We return. Oh, there is hissing. There you go. And then we can instantiate our Rex. It's our dog. And I don't know, meow. It's our cat. So if I have encounter, if Rex encounter meow, oh, there's a chase. Now, if there is the opposite, if meow encounters Rex, oh, there is a hissing. That's how we do it. And suppose we have like a giraffe. So, and it's a subtype of pet. And then you have like encounter Rex, and then you instantiate the giraffe. I don't know, let's call I don't know, a nice name for giraffe. Let's call him Gottfried. Okay, so Gottfried is a giraffe. And if Rex or are abstract and that have questions. Okay, so I think I'm back. Okay, sorry about that. There was a small issue here in my internet. So, sorry about that. I'm back. Almost. Yes, I'm back. Thank you. So, where did I miss you guys? So we define an abstract type pet. Then we define structs called dogs and cats that are subtypes of pet. And we define a function that is an abstract function that's a fallback encounter between two pets. That's the abstract type. And we define custom behavior if either a dog meets a cat or a cat meets a dog. And we also define a struct called giraffe and we define a object called Gottfried, which is a giraffe. And whenever we call hex encounters Gottfried, there is the fallback. So that's it. So that was a basic introduction to Julia. Let me just see if we have any questions, and let me stop. Let me go back to the here. So thanks for attending. I hope you guys have a great JuliaCon. We are really excited. There's a lot of great workshops. There are a lot of lightning talks, a lot of panels, a lot of keynote speakers. So don't miss our JuliaCon is starting today. Go to the conference schedule and don't miss the workshops during this week and the talks next week. So that's it, folks. Thank you. And we are going to end the broadcast now. Bye-bye.